So for example 14, find and classify all points of inflection of this graph. X to the power of 4 subtract 4x cubed plus 5. So let's decode what's asking of us. We're looking at points of inflection. So we know that these occur when the second derivative is equal to 0. So we need to find them, find those points. So that's telling us we need x and y coordinates for them. And we need to classify those points. So that's telling us we need to decide or figure out whether they are stationary or non-stationary. Okay, we can do this. Let's look at the first derivative. Four x cubed subtract 12x squared. And let's draw a sign diagram for that first derivative. We need to find our critical values. There's no asymptotes, but there will be zeros. So we're setting this equal to 0 to find the zeros. And the zeros are 0 and 3. We could place some values in there. We could do this algebraically by testing some values in each of those intervals, or we could do it graphically by looking at the graph of the function and seeing which intervals are above the x-axis and which intervals are below the x-axis. I'll let you choose whichever way you want to do this. I'll just fill in the signs. So this means that the function is decreasing in this interval, and increasing in this interval. All right, let's look at the second derivative. 12x squared subtract 24x. And let's draw a sign diagram of it. So this one was the first derivative sign diagram. Sign diagram of the second derivative. What are the zeros? The zeros are 0 and 2. Again, you can either look at the graph or test some values in each of those intervals. The sign diagram is this. That means that in this interval on our original function, it's concave up. Here it's concave down. Here it's concave up. Okay, so this is our preliminary information. We're asked to find and classify all the points of inflection. So we know the points of inflection are these x values, happen at these x values on our second derivative. So we should find those points then. So f of 0, plug 0 into our original function and we will get 5. So we have the point 0, 5. F of 2, plug 2 into our original function and we get negative 11. So we have this point 2, negative 11. Those are our 2 points of inflection. We need to classify these points now. So remember, if f of a is equal to 0, that will be one situation. If f derivative of a is not equal to 0, that will be the other situation. And this one will be a stationary point. This one, a stationary inflection point. This one will be a non-stationary inflection point. So let's test that. f dash of 0, so 0 into our derivative function, will give us 0. Okay, so therefore 0, 5 is a stationary point of inflection. And test f dash 2. That does not equal 0. It equals -16, I believe. So therefore 2, -11 is a non-stationary point of inflection. There we go. So we're using the derivative, we're using the second derivative, finding the points, and categorizing them.